So here we go. We're going to go over solving equations. Okay? Solving and evaluating equations are two different things. When you're solving, that's where we use our good old friend PEMDAS. Y'all remember PEMDAS? Okay?
Please excuse my dear Aunt Sally.
Not just please excuse my dear Aunt Sally, but what it stands for.
Plus, equal, divide, add, subtract.
Okay? So,
Plus equal divide.
PEMDAS. PEMDAS means that we're going to
Interrupting our class. Thanks, Dawn. I'm trying to learn.
PEMDAS means that you are PEMDAS, for the third time trying to speak, means that you are actually evaluating. PEMDAS means that I have a problem and I am evaluating that problem.
Would you press record?
Yes. PEMDAS means I am evaluating.
Wait, so you have my whole PEMDAS thing?
It doesn't record your voice.
Yes, it does.
Oh, it does?
PEMDAS. It means you're evaluating. Typically, there is no variable present. Okay? That's when you use PEMDAS. Like if I set parentheses 3 plus 2 close parentheses squared minus 1/2 times 11 divided by 13. You would use PEMDAS to solve that. Okay? Because did I say any variable? No, I just want to know what is the solution for this. That's called PEMDAS. That's when you use PEMDAS. However, when you are solving, we're not using PEMDAS. We're using what I call SADMEP.
Did you make this up?
I guess.
I think they told it to.
No. SADMEP. Okay? SADMEP is essentially PEMDAS backwards. Okay? SADMEP is for when you are solving. And when you are solving for something, that typically means that there is a variable. And your goal is to get that variable alone. So you don't work in the order of PEMDAS. It's like you are unwrapping your present. So PEMDAS, you are wrapping the present. You're trying to make it all pretty and get to one answer, right? Well, with SADMEP, you're unwrapping that present, you're tearing it apart, and you're trying to figure out where did it come from, how did it get there? Yes?
So you're working backwards?
You're working backwards, okay?
So you would subtract first?
You would add or subtract first, depending on which one is present. You would multiply or divide, depending on which one is present. You will work on getting rid of the exponent, depending on what's there. And then you will work on setting your parentheses free. Okay? So, with SADMEP, this is my little analogy. So we know it as, please excuse my dear Aunt Sally, right? For SADMEP, I said, I've been thinking, why are we forgiving and excusing dear Aunt Sally? I figured it out. So, SADMEP, sorry, Auntie didn't make enough pie. So that's why we're excusing her. She didn't make enough pie to feed everybody. So that is how SADMEP comes into play.
I like that.
Thanks. All right. So we're going to be using SADMEP and going from there. Not that long. All right. So when we look here, the first thing we have is 3x divided by 2 minus 1/4 times x minus 5 equals 10. Is this a solving or a evaluating problem?
Evaluating. This is solving.
Why is it solving?
Because it has a variable.
Because I have a variable present. Yes.
Wait, we're using it exactly backwards?
No, it's going to be versatile. But yes.
So I was going to say.
Okay? Now, before you start evaluating something, your goal is to get it to as few terms as possible. So in the case of this problem, instead of having it as 2 terms, we only want 1 term. Okay? So in order to get 1 term, that means we need to combine these 2 fractions. So when I write it as 3x over 2 minus x minus 5 over 4 equals 10, does that freak anyone out?
Yes.
No.
Wait.
A little bit.
Because all you did was multiply
Did you just
1
distribute?
and x5.
What denominator does every number have or every expression has? 1. So all I did was do 1/4 times 3x minus 5 over 1. And I combine them, right?
Yep.
Does that make sense?
Yep.
All right, so I can, now that it's in this form, can I even make one more?
Probably.
Can I make another one? All right, so how would I combine these two fractions?
What if your numerator would have been like 2, would have been 2x minus 10?
What do you mean?
Like if it was 2 over 4, it would have been 2x minus 10.
Why would it be 2x minus 10?
Because isn't that what you did? Like, didn't you just multiply x minus 5 into 1?
Yeah, like x minus 5 over 1. So 1 times x minus 5 is x minus 5, and 4 times 1 is 4.
So if it would have been 2, like that's what I'm saying.
Which part being 2? I'm not understanding.
Like, you know how it's 1/4?
Yes.
What if it would have been like 2/4? Would it?
Then it would have been 1/2, and I would have written x minus 5 over 2.
All right, touche.
Yeah. Okay. All right. So how do I make these together? How do I make them one?
Chopsticks.
I could do chopsticks or
Nothing else.
LCD, right? Okay. I could do LCD here because this is easy. What's the LCD between 2 and 4? 4. So this 4 is fine, right? But how can I make 2 into a 4?
6x over 4 because it's
I'm going to multiply by 2. What I do to the bottom, I have to do to the... Okay, so 2 times 3 is going to give me
6x.
minus x minus 5. And what's my LCD?
4.
4. So I combine my numerators over my LCD. Remember that from our notes? You combine your numerator over your LCD. Can I simplify my numerator?
Yes.
Yes, I can distribute and combine like terms. So I can distribute, and I'm going to end up with 6x minus x plus 5 over 4.
So you use minus?
I distribute my negative, because what's technically here? A negative 1. So I distribute my negative 1. Now how do I keep simplifying it?
Go 5x plus 5.
So now I have 5x plus 5 over, and this all equals, just bringing my 10 down. At this point, can you solve that?
Yes.
Solve it
Ourselves?
by yourself.
You don't get 10x.
Why do you want to use 10x so bad? You're not stupid. You just like 10x.
So what do we do?
Solving for x.
What is that thing? That little thing that can move on the side. No, it's on that bar. Just click the red one. It's right above the red. Yeah.
The size.
21. What did you take away the 5 first? Or should take the 4? I should keep refilling the ink. I have to get it done. Wow. So you just like, well, what you did lump, you know, you did it yourself? I don't know why.
Alright, so hopefully y'all remember. If I'm dividing by 4, how do I move it? Multiply by 4. So this will be times 4, and what happens? It goes away. What I do to one side, I have to do to the other. So now I have 5x plus 5 equals 40. I'm going to roll the screen up.
21.
So what do I do now? I'm going to subtract 5. Remember, SADMEP. Before I can do this, I have to do this. So now I have 5x equals 35. And my last step? Divide by 5.
What's the outside of the parentheses? Is that
A 4. So my answer had to be
21.
7.
What happened to your old thing?
What old thing?
The one that had
The lid? The smart bottle?
the calorie.
Oh, someone knocked it off and broke it.
Why'd you take off the 4?
Why did I take off the 4? What do you mean?
I can move it over again.
Because I'm trying to get x by itself, right? And so before I can do anything to this, the numerator, you have to remove the denominator. And so this is division. The opposite of division is multiplication. If I multiply this side to get rid of the 4, then I have to move the 4 to this side. You have to keep it balanced. That's what the equal sign means. Must stay balanced at all times.
But you know what side you gotta do?
Yep. Just like with the fraction, whatever you do to the top, to the bottom, you have to do to the top. All right, here we go. We're going to get a little harder. Okay, so now we have 5x squared plus 3x minus 2. When you look here, you notice that I have 3 terms, correct?
Yep.
I have 3 terms, but I also have 2 different types of variables. I have x squared and I have x. Okay? What that tells me is that I can't just solve for one of them. I can't just solve for x squared and I can't just solve for x. However, we know how to factor this, right? We know how to factor this to get down to where just each part has how many x's in them? 1. Okay? So our job is going to be to factor this. I can either, yes, Kobe.
If you take the square off the first x, the x's will they equal the same?
No. You can't just take the square off.
So I say you like a different variable.
Yeah.
He's like, wow.
Because you're still squaring, the squaring power is going to make it different either way. The fact that it's being squared is what matters. Okay, so I can cab. If I do quadratic, quadratic leads me directly to my answer. So you could do quadratic and go directly to your answer, or you could do cab and then end up at your answer. Okay? Either way, you're going to end up with your answer. Okay, so with cab, since you're more comfortable with that, C times A and B. So 5 times negative 2 is negative 10. We agree? And my B is, so it multiplies to give me negative 10, but adds to give me 3.
5 and negative 2.
A 5 and a negative 2. Okay, so once I have those numbers, I can put it inside my little box. And I get 5x squared, and I get
2.
negative 2, negative 2x, and 5x. Greatest common factor here is just x. Greatest common factor here is a 1. Greatest common factor here is a 5x. Greatest common factor here is a negative 2. So my factors have to be 5x minus 2 and x plus 1. Are we all comfortable with CAB?
No,
Okay, why are you not comfortable with CAB?
because it's confusing.
Okay, if you're uncomfortable with CAB, you can always use the quadratic.
Quadratic always seems,
Yep.
It's too long.
it's a longer process.
You can also plug it into a calculator.
You can't. You're not testing with a calculator. This test, you will not be able to use a calculator.
What test?
Now, one time I told you to use a calculator for this.
What test?
Yeah.
Your quiz or your test.
Our test?
Like, no, your quiz in the
That's-
class,
I
your
was about to say, I
test in the
didn't think we
class.
had one.
When is the quiz?
Your quiz is next Tuesday.
I thought you were going to say tomorrow.
All right, now that I have 2 factors, what that means now is that mathematically it's okay for me to separate them, as long as I'm making both factors equal 0. So mathematically, it is okay for me to separate these 2 and make them both equal 0. So I can have 5x minus 2 equals 0, and I can have x plus 1 equals 0.
And we just solve.
And then you just solve.
And those are the answers.
And those are your answers. So when I solve, I would add 2, and I get 5x equals 2. Divide by 5, divide by 5, and so I get x equals 2/5, or I can write it as 4/10. Huh?
No, I'm just talking.
Oh,
What did you write it as? 0.4?
Huh?
I already did it. You just ended it with.
Denitra will probably do the quadratic.
She doesn't like cap.
She doesn't like cap.
She always makes stuff so difficult.
Okay.
And x equals obviously -1, right?
Nope.
The only way to make a positive number equal 0 is to add its negative. It's call its opposites. Reciprocal means you're flipping.
Who was that reciprocal?
Okay? Notice here, how many solutions did I have? And what is my greatest exponent? 2. Depending on what your greatest exponent is, that's how many possible answers you could have. Okay? Notice on the first one, my greatest exponent was only 1. So how many solutions should I have? 1. Okay? How many solutions should I get out of 3?
2.
2. Okay? Because I only have one variable present, I can just solve for this like normal. So am I using SADMEP or PEMDAS? SADMEP. So according to SADMEP, is there any subtraction or addition I need to get rid of? Yes, I need to get rid of 48. How do I move it? What I do to one side, I'm going to do to the
Other.
So I have 3x squared equals 48. Now do I have any multiplication or division to get rid of? Do I have any exponents to get rid of?
Yes.
How do I get rid of the square root of something? There you go, I gave you the answer. You gave it to me as well. When you take the square root of something,
Forward.
what kind of 4?
Positive 4.
Or a negative 4. All right, Carl is going to do the problem for us.
Thanks, Carl.
He says he feels better about the board now.
Carl is offended.
Carl
I
is
think he's
like,
got the hang of it.
Yeah.
He's using his left hand.
he's doing better.
Is this the second time?
Good job.
It's meant for right-handed users. The fact that he's using his
Okay.
right hand helps. It could be completely flipped.
Y'all talking stuff about my writing?
No, you're doing
The
good.
writing isn't that bad.
So I remember last time he was like, forgive me. He said that. So this is crazy.
I'm still talking. He gets on and on.
You're right.
That's how people write weird. You know what you're expecting.
Keep going, Carl. Good job, Carl. Thank you, sir.
Yeah, thanks.
All right. It is a plus or minus square root of 2, right? Not imaginary. Imaginary means there's a negative underneath the square root. All right, on to the back.
I give up.
Don't give up. The fun just began.
Yeah.
Begun.
I thought I had it.
Has it begun? Begun.
21.
I thought
All
I had
right.
the hang of it.
I know.
So, again, how many variables, different types of variables do I have now?
3.
3. So that really means that I need to, what's the F word? Factor. How do I factor this? Grouping. Look at that. We're so smart. So I'm going to group the first 2 and group the last 2. Okay? When you're grouping, I'm finding the GCF of each group, right? So what's the GCF of my first group?
X squared.
Beautiful.
So it's be x minus 1.
So I'm going to be left with
X minus 1.
lovely. What's the GCF of this?
9.
What kind of 9 do I want to take out?
Negative.
Negative 9, because I want this one to be
Negative.
positive. I want to lead positive. And also I want to make it look like, yes sir.
Why'd you get rid of the 2?
Yeah, why do you really?
Did I move it? Oh,
You never even placed it.
sorry. It knew it wanted to be there. Thank you. All right, what's the GCF of these 2 terms now? And then what am I left with? And what makes x squared minus 9 special?
It's a difference of squares.
It's a difference of squares. It's a DOS. So once I'm in factored form, what can I do to each one of these? What did we just
Set them
do?
equal to 0.
I can separate them and set them each equal to 0, right?
Yeah.
So now I have three smaller problems to work with. Okay? So find my answers, please.
I see why they keep.
Little jingle.
Really?
I'm just
No, you meant that.
no.
Did you hear her say?
Unfortunately.
So we're doing like three of those, right?
No.
What are we doing? No, what I'm saying, like, what these, does that mean plus or minus?
Oh, well, yeah. All right, 2x minus 1, what's x?
X equals plus or minus half.
Not plus or minus, it wasn't the square
Oh,
root.
yeah, half.
So it's just a,
Half.
Doesn't x have you divide by 2, right?
You only write plus or minus when you're taking the square root of
No, I
something.
mean, it's 2x and then you add 1, so it's 2x equals 1
Mhm.
divided by 2.
And then these have to be the opposites, right?
X equals -3.
So on that we can do plus or minus.
X equals +3.
Yes, take. I can there. To save pen and pencil, I will write. I'm not wasting any. All right, how do we feel?
Perfect.
Terrifying.
Oh, wait, you didn't do that.
I did. I wrote plus or minus. Yari.
Why is it the 1.5 plus or minus?
Because I didn't take the square root. It's literally, it gave me a final answer.
And we do the square root of that one?
No.
Because this right here would be what?
Negative.
Positive.
This will be a negative and this will be a, so I can just write
Plus or minus.
plus or minus 3. If you want to write them separately, you may write them separately. Okay. All right. Let's go on to 6. All right, so 6.
2.
How many variables? 2. What's my highest exponent? 4. So that means I could have potentially up to how many answers?
4.
4 answers. All right? Huh? You need to think about it. I'm sorry. The thing is, I need to get everything on one side and get the problem equal to 0. Okay? That's option number 1. Option number 2 is I can get only my variables to one side and leave my problem equal to -1. So we're going to do both. So I want you to split your page in half so that you can see how doing both will lead you to the same answer. Okay, so option 1 is to get all terms on one side and set it equal to 0. So I'm going to move my 2x squared. Since it's positive, when I move it, it's going to become a negative. I'm going to move my -1, and since it's negative, when I move it, it's going to become a, and set it equal to 0. Okay? Once I've done this, this is just mental math. So because this is just mental math, I know that this has to be x to the 4, I mean x to the 2. Because x squared times x squared is going to equal x to the 4th, right? All right, so what adds together to give me -2, but multiplies to give me +1? Huh? Not -1 and 2, but -1 and -1. Because a negative times a negative is a positive, but a negative plus a negative is still a negative. Okay? And now they equal 0. So I have x squared minus 1 equals 0. What would x squared x have to be?
X squared
Add 1.
equals
X equals 1.
positive or negative square root of 1.
There you go. Not square root of 1, but square root of 1.
Oh, 1.
How did you get rid of the weight? One of the x squared.
I didn't have to do them both because they're the same. So I only need to do it one time. If I do it 2 times, is my answer going to change?
No.
No. Okay, so that's way number 1.
Weight number 2.
Way number 2. So your option number 2 of doing the problem is you could have just gotten your variables on one side. So I would have x minus x to the 4th equals, sorry, forgot the minus, minus 2x squared equals negative 1. And between these two, what's their GCF? So I would have had x squared times okay, now this is multiplication. So I have this, I have x squared equals negative 1, and then I have x squared minus 2 equals negative 1. No one's home.
That one confused me.
Hey. Mm-hmm. It's just 30-70, 70% for daily, 30 for test. That's all you can do. You can't have participation. Like, you'll just have to be built into your daily. But you can't have a participation section. No, you put, like, you just grab the 70 and you grab the 30. Because you can't grab the participation. Got it? All right. Weird. All right, so what were we doing? Say option 2. So with option 2, I would take the square root, right? And I end up with x equals plus or minus 1. Here, I'm going to add 2, which gives me x squared equals 1. Take the square root, and I'm going to still end up with x equals plus or minus 1. So either way, I'm going to still end up with my answer being x equals plus or minus 1.
I thought you had a negative under the square root sign. It was a negative.
Why would I have a negative? You owed me $1 and you gave me 2?
On the side.
Was it
X
negative?
squared equals.
Oh, sorry. Yes. No solution from this. Thank you, Kobe. So then that means we'd have to use this one as our only possible solution. I didn't even pay attention to the negative. Good job, Kobe.
Wait, don't take it off.
All right, come on. We gotta get to the 7 so you can have it for your homework.
Well, you confused me. Well, just go ahead and figure it out.
Alright.
Go.
Just storm through it.
All right, on 7. Notice we have fractions, right? It's in the denominator, and so before we do anything, we need to make sure that everything is now in the numerator. So, same concept, chopsticks possible, and I can do 6 times x plus 5 plus 8x all over x times x plus 5 equals 3. I either can do LCD or chopsticks to end up at this point. Okay? Once I'm at this point, I want to take this whole thing out of the denominator. So if I'm dividing, what's the opposite? Multiply. So I'm going to multiply this whole side by x times x plus 5. So now I'm just going to simplify. So 6 times x is 6 times 5 is plus 8x. Over here I have 3x times x is 3x squared. And I have 3x times x is 3x. 3x plus 5 is 15x. So I double distribute.
So this one you do distribute?
Mm-hmm. Because now I went from being in this format to now I'm being in this format. So can I now get all of my variables on one side to solve this problem? Yes, I just got to start moving everything. I want this to stay positive because it's my largest. And I'm going to start moving everybody to the other side. So minus 14x minus 30 So I have 0 equal 3x squared plus x minus 30.
Why is there a minus 30?
Why? Because it's a positive 30. So when I move it, it's going to become a...
What about the 6?
I did 6x plus 8x. Bye. Have a good day, students. Bye, Carl. No, can I? What do I do now? I factor and I cast, and then I set them equal to 0. So if I finish it, I'm going to finish it. So here, I can cap it, and I get negative 90, and I have a positive 1. So what times what gives me negative 90? 10 and 9. What kind of 10 and 9? I'm not paying attention. Okay. Okay. So once I have those numbers, Adam, ready to go home? Oh.
Trying to figure out why are you torturing all these kids? This is torture. Yeah, make them stay and do math and whatnot.
Okay. They're choosing to stay?
Oh. We ain't got a very smart class.
Can I find my answers now?
No.
What would I do, Charlie? To solve for x? No, I'm right here. So what would I do to solve for my answers? I want to get x by itself now. So I would subtract 10 and then... No, it's multiplication. Opposite multiplication is... So when I subtract 10, I'm going to end up with a negative 10. And I'm going to divide by 3. On here, what will this one have to be? A positive 3.
Why would you have 2?
Why would I have 2 answers? What's my highest? My highest exponent is?
I don't get this.
Okay, which part?
Everything, like everything. I'm still on yesterday's homework.
Should we reduce it or just leave it like that?
That's reduced.
Reduce it?